Hello, in this lecture we'll find out the value of angle x using two different methods. In the drawing we have triangle PQR. We know that QS equals to SR. We also know that angle PSQ, this angle, equals to 45 degrees. Angle PQS, this angle equals to 3x. Angle PRQ equals to x. And we want to find out the value of x. Okay, so first of all, we will define angle PQP as alpha. And we will also define angle SPR as beta. And what is the size of angle PSR? According to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we look on the upper side of the straight line QR at point S, then the sum of the angles must be equal to 180 degrees. That is to say 45 degrees plus x must be equal to 180 degrees. So here we will subtract 45 degrees from this equation, and we will get that angle x equals to 180 degrees minus 45 degrees is 135 degrees. So we found out that angle x equals to 135 degrees. So we can write here that angle x equals to 135 degrees. And in the next step, I will present to you a new rule, or actually the law of sines. What is the law of sines? Actually, the law of sines is true for any triangle so we can write that in any triangle if we have a triangle we know that the length of this side is a units, and the opposite angle is angle A, and we also know that the length of this side is B units, and the opposite angle that is in front of angle B is B, and we also know that the length of this side is C units, and the opposite angle that is in front of side C is C. Then, according to the law of sines, A over sinus A equals to B over sinus B equals to C over sinus C. Okay? I'll repeat again. In any triangle, if the length of this side is A, the length of this side is B, and the length of this side is C, then A over sine A equals to B over sine B equals to C over sine C. So from this formula we can derive that B over sine B equals to A over sine A and if we divide this formula by A and then multiply it by sinus beta, we will get that, actually we will divide this formula by B and then we will multiply it by sinus alpha. We will get that A over B equals to sine A over sine B. So according to this formula, the ratio between the side lengths of any triangle equals to the ratio between the opposite angles. Okay? And we can actually implement this rule in our drawing. First of all, we know that QS equals to SR, so PS over QS equals to PS over SR. And this is because of the fact that QS equals to SR according to what is given us in the question. So according to the rule that the ratio between the side lengths of any triangle equals to the ratio between their opposite angles, we will get that PS over QS, if you focus on triangle PQS, then PS over QS, it will be equal to sine 3x over sine alpha. And PS over SR will be equal to sine X over sine beta. Okay, we found out that sine 3x over sine alpha equals to sine x over sine beta according to equation number 1. And then, if we focus on triangle PQS, on triangle PQS we know that the sum of the angles of triangle PQS is equal to 180 degrees. That is to say, alpha plus 3x plus 45 degrees must be equal to 180 degrees. I repeat again. According to the rule that the sum of the angles in any triangle is equal to 180 degrees, we will get that in triangle PQS, alpha plus 3x plus 45 degrees equals to 180 degrees. Here we will subtract 45 degrees and 3x from this equation, equation number 2, and we will get that angle alpha equals to 180 degrees minus 3x plus 45 degrees. So we found out the value of angle alpha in terms of x. Likewise, in triangle PSR, this triangle, we know that the sum of the angles is equal to 180 degrees. That is to say, this angle is beta plus 145 degrees plus x must be equal to 180 degrees. I'll repeat again. In triangle PSR, beta plus 135 degrees plus x must be equal to 180 degrees. Here we will subtract 135 degrees and also x from this equation, equation number 2, and we will get that angle beta equals to 45 degrees minus x. Again, we found the value of beta in terms of x, so we will actually substitute angles alpha and beta in equation number 1. This equation by the values that we found in equation number 2 and equation number 3. We'll do it now. According to equation number 1, sinus 3x over sinus alpha. And we have already found out that according to equation number 2, alpha equals to 180 degrees minus 3x plus 45 degrees. So we'll substitute alpha by this expression, and it equals to sinus x over sinus beta. And we have already found out that beta equals to 45 degrees minus x, so we will substitute beta in equation number 1 by 45 degrees minus x. For equation number 3, and we have the trigonometric identity that states that sinus 100 degrees minus theta equals to sinus theta. So according to this trigonometric identity, sinus of 100 degrees, 180 degrees minus 3x plus 45 degrees will be equal to sinus 3x plus 45 degrees. So we write it down. We will get that according to equation number 1, sinus 3x over sine 45 degrees plus 3x equals to sine x over sine 45 degrees minus x I repeat again, we got that according to equation number 1, sine 3x over sine 45 degrees plus 3x equals to sine x over sine 45 degrees minus x. Here we will cross multiply equation number 1 and we will get that sine 3x times sine 45 degrees minus x equals to sine x times sine 45 degrees plus 3x. Here we will multiply equation number 1 by 2 and we will get that two times sine 3x times sine 45 degrees minus x equals to 2 times sine x times sine 45 degrees plus 3x so here we will use the trigonometric identity that 2 sine A sine B equals to cosine A minus B minus cosine A plus B. So according to this trigonometric identity, we will get that in our specific equation, A is equal to 3x and B equals to 45 degrees minus x. So 2 sine 3x times sine 45 degrees minus x, according to this trigonometric identity, will be equal to cosine A minus B. Cosine A is 3x and B is 45 degrees minus x. And 3x minus minus x is 4x. Minus 45 degrees. Minus cosine A plus B. A is 3x, B is 45 degrees minus x, so A plus B is 3x minus x is 2x minus 45 degrees. So we finished with this side of equation number 1. Now we will do the other side of equation number 1. In 2 sine x sine 45 degrees plus x, here A will be equal to x and B will be equal to 45 degrees plus x. A equals to x and B equals to 45 degrees plus 3x. So 2 sine x sine 45 degrees plus 3x, according to this trigonometric identity, will be equal to cosine A minus B. That is to say, x plus 3x is 4x plus 45 degrees minus cosine A minus B. So it is cosine x minus 3x is minus 2x, and 0 minus 45 degrees is minus 45 degrees. And according to the trigonometric identity that cosine minus x equals to cosine x, we can substitute cosine minus 2x plus 45 degrees, cosine minus 2x plus 45 degrees, to cosine 2x plus 45 degrees. We will turn the minus to plus, according to the trigonometric identity that cosine minus x equals to cosine x. So here in conclusion, we got that according to equation number 1, cosine 4x minus 45 degrees plus cosine 2x plus 45 degrees equals to so we got that cosine 4x minus 45 degrees minus cosine 2x plus 45 degrees equals to cosine 2x plus 45 degrees minus cosine 4x plus 45 degrees. So in conclusion, we will get that cosine 4x minus 45 degrees plus cosine according to equation number 1, cosine 4x minus 45 degrees plus cosine 4x plus 45 degrees equals to 2 times cosine 2x plus 45 degrees. Okay. So we have here, we will simplify this expression according to the trigonometric identity that cosine C plus cosine D equals to 2 cosine C plus D over 2 times cosine C minus D over 2. Okay, and in order to simplify the expression cosine 2x plus 45 degrees, we will use the trigonometric identity that cosine A plus B equals to cosine A times cosine B minus sine A times sine B. So cosine 4x minus 45 degrees plus cosine 4x plus 45 degrees, according to this trigonometric identity, we will get that C equals to 4x minus 45 degrees and D equals to 4x plus 45 degrees. So according to this trigonometric identity, we get that cosine 4x minus 45 degrees plus cosine 4x plus 45 degrees, it equals actually to 2 cosine C minus C plus D over 2. C is 4x minus 45 degrees and D is 4x plus 45 degrees. So C plus D is 4x plus 4x is 8x over 2 is 4x, and minus 45 degrees plus 45 degrees is 0. So it is 2 cosine C plus D over 2 times cosine C minus D over 2. C minus D is 4x minus 4x is 0, so it is minus 45 degrees. Minus 45 degrees is minus 90 degrees over 2 is minus 45 degrees. But we know that cosine minus x equals to cosine x, so cosine minus 45 degrees equals to cosine 45 degrees. And then 2 cosine 2x plus 45 degrees, here A equals to 2x, B equals to 45 degrees, and according to the trigonometric identity that cosine A plus B equals to cosine A times cosine B minus sine A times sine B, we will get that 2 times cosine 2x plus 45 degrees, it actually equals to 2 cosine A times cosine B, that is to say cosine 2x, A is 2x, so it is cosine 2x times cosine 45 degrees, because B is 45 degrees, minus sine A is 2x, so it is minus sine 2x times sine 45 degrees. So here we will divide this equation number 1 by 2 cosine 45 degrees. So here 2 cosine 45 degrees will get cancelled. Here also 2 cosine 45 degrees will get cancelled. And here we have, because of the fact that sine 45 degrees equals to cosine 45 degrees, here 2 sine 45 degrees will get cancelled. And what is left from equation number 1 after we cancel 2 cosine 45 degrees? What is left? It is actually cosine 4x equals to cosine 2x minus sine 2x. Okay? So here we will add sine 2x to this equation number 1, and we will subtract cosinus 4x. We'll add sinus 2x and subtract cosine 4x from this equation number 1, and we will get that sine 2x equals to cosine 2x minus cosine 4x. We know that sine x equals to 2 sine x cosine x, so I write it down. And cosine 2x minus cosine 4x, we will find the value of cosine 2x minus cosine 4x according to the trigonometric identity that states that cosine C minus cosine D equals to 2 sine D plus C over 2 times sine D minus C over 2. Okay? So, in our specific equation number 1, C equals to 2x and D equals to 4x. So actually cosine C minus cosine D is 2 sine D plus C. That is to say, it equals to 2 sine D plus C. D is 2x, D is 4x, C is 2x, so 2x plus 4x is 6x, 6x over 2 is 3x, times sine D minus C over 2. Sine D minus C. D is 4x, C is 2x, so 4x minus 2x is 2x, and 2x over 2 is x. So in conclusion, we found out that 2 sine x cosine x equals to 2 sine 3x times sine x. So here we will divide this equation number 1, by 2 sine x. Okay. And what is left from equation number 1 after we cancel 2 sine x? What is left is cosine x equals to sine 3x. But we have the trigonometric identity that cosine alpha equals to sine 90 degrees minus alpha. According to this trigonometric identity, we will get that cosine x equals to sine 90 degrees minus x, and it equals to sine 3x. So we got that sine 90 degrees minus x equals to sine 3x. That is to say, 90 degrees minus x equals to 3x. Here we will add x to this equation, and we will get that 90 degrees equals to 3x plus x is 4x. So we will divide this equation by 4, and we will get that x equals to 90 degrees over 4. And 90 degrees over 4 is 22.5 degrees. So we found out that angle x equals to 22.5 degrees. Again, the value of angle x is 22.5 degrees. We finished with the first method. In the next step, I will present to you how to find out the value of x according to the second method. In the second method, we will define angle QPS as alpha, and we will also define angle SPR as beta. We have already found out that this angle equals to 135 degrees, so I will not repeat on it. And again, we know that the sum of the angles in any triangle equals to 180 degrees. So in triangle PQS, the sum of the angles is equal to 180 degrees. That is to say, alpha plus 3x plus 45 degrees must be equal to 180 degrees. Here we will subtract 45 degrees from equation number 1, and we will get that alpha plus 3x equals to 180 degrees minus 45 degrees is 135 degrees. So we found out that according to equation number 1, alpha plus 3x equals to 135 degrees. So this was on triangle PQS. We will do the same process On the other triangle, triangle PSR. On triangle PSR, we also note that the sum of its angles must be equal to 180 degrees. That is to say, here we have angle beta plus this angle is 135 degrees plus this angle, that is angle x. The sum of those three angles must be equal to 180 degrees. So here we will subtract 135 degrees from this equation, equation number 2, and we will get that beta plus x equals to 180 degrees minus 135 degrees is 45 degrees. Here we will multiply equation number 2 by 3, and we will get that 3 beta plus 3x equals to 135 degrees. So according to equation number 1, 100 plus 3, alpha plus 3x equals to 135 degrees. And according to equation number 2, 3 beta plus 3x equals to 135 degrees. Because of the fact that they have one side, the right side on both those two equations is equal to 135 degrees. We can create equation number 3 that states that the left side of equation number 1 equals to the left side of equation number 2. That is to say, the left side of equation number 1 is alpha plus 3x. That equals to 135 degrees. And 3 beta plus 3x also equals to 135 degrees. Therefore, those two expressions are equal to each other. So here we will subtract 3x from this equation, equation number 3, and we will get that according to equation number 3, alpha is equal to 3 beta. We found out that according to equation number 3, alpha equals to 3 beta. Here we will do a construction. We will draw a straight line from point Q to PR, to side PR, in such a way that this angle will be equal to x. Okay? So this angle equals to x. Because of the fact that angle PQR equals to 3x and this angle equals to x, then this angle must be equal to 2x. We will define the touching point from of the straight line from point Q to PR as point M. Actually, in triangle QMR, in this triangle QMR, we have two angles that are equal to each other. They are both equal to x. Therefore, triangle QMR is an isosceles triangle. And because of the fact that triangle MQR is an isosceles triangle, QR is the base of the isosceles triangle, triangle QMR. We will join points M and S together by a straight line. What is MS? The segment line MS is the median of the isosceles triangle, triangle QMR. Is the median that bisects the base of the isosceles triangle, triangle QMR into two equal parts. Because we know that according to what is given us in the question, QS equals to SR. So the median MS, as it is defined, is bisects the base of the isosceles triangle, triangle QMR into two equal parts. But according to rule number 3, it is not only bisects the base of the isosceles triangle, triangle QMR, but it is also perpendicular to the base. That is to say, this angle is a right angle, it equals to 90 degrees. And this angle, it is also a right angle, it equals to 90 degrees. Okay? In the next step, I will present to you a new rule, rule number 4. According to rule number 4, the exterior angle of a triangle of a triangle is equal to the sum of the angles that are not adjacent to it. So I'll read rule number 4 again. According to rule number 4, the exterior angle of a triangle is equal to the sum of the angles that are not adjacent to it. So what is the meaning of rule number 4? The meaning of rule number 4 is that if we have triangle ABC, this is angle alpha, this is angle beta, this is angle gamma. This is triangle ABC. So angles alpha, beta and gamma are the angles that located inside triangle ABC, and this angle CSAC, angle SAC, this angle is defined as an exterior angle of triangle ABC. Okay, angle SAC is defined as an exterior angle of triangle ABC, and according to rule number 4, the exterior angle SAC of triangle ABC is equal to the sum of the angles that are not adjacent to it. As you can see, angle gamma is adjacent to angle SAC. They are adjacent to each other, and the only two angles that are not adjacent to angle SAC are angle alpha and beta. And according to rule number 4, the value of angle SAC is equal to the sum of the angles that are not adjacent to this angle. So it is actually equals to alpha plus beta, because those are the two angles that are not adjacent to angle SAC. So it equals to alpha plus beta. The exterior angle SAC equals to alpha plus beta. Okay? And it is true in any triangle. We can implement rule number 4 in our drawing, because in our drawing we have the isosceles triangle, triangle QMR, and we have angle PMQ is an exterior angle of the isosceles triangle, triangle QMR. And according to rule number 4, the value of the exterior angle PMQ, this angle, it equals to the sum of the angles that are not adjacent to it. This angle is adjacent to it, and only two other angles that are not adjacent to this angle PMQ in triangle QMR are X and X. And according to rule number 4, it equals to the sum of the angles that are not adjacent to it, that is to say it equals to angle X plus angle X, that is to say it equals to 2X. Okay? Equals to 2X. So here in triangle PQM we have two angles that are equal to each other, therefore it is triangle PQM is an isosceles triangle. That is to say PQ equals to PM. PQ equals to PM according to the rule that in front of equal angles in the triangle there are equal sides. Those two angles are located in front of angle PQ and PM in triangle PQM, therefore PQ equals to PM. We can write down that PQ equals to PM in triangle PQM we found out that PQ equals to PM. Again, PQ equals to PM. You can also write here that PQ equals to PM. And we will focus on those two triangles. First of all, we will draw from point P, we will draw perpendicular to QM. That is to say, this angle will be equal to 90 degrees and this angle also will be equal to each other, and we will extend the perpendicular until it hits side QS, and we will define the touching point between the perpendicular from P to QS as angle S point N, and then we will define the touching point between the perpendicular to QM as L. So this angle equals to 90 degrees and this angle also equals to 90 degrees. We will focus on triangles PQL, triangle PQL and triangle PLM. We'll focus on those two triangles. We know that those two angles are equal to each other, they are both equal to 2x. So angle PQL in triangle PQL is equal to angle PML, and both angles are equal to 2x. Okay? Angle PQL equals to angle PML equals to 2x. We focus on triangle PQL and PLM. We also have those two angles that are both equal to each other, they are both equal to 90 degrees. So angle PLQ equals to angle PLM, and both angles are right angles, that is to say they are equal to 90 degrees. I will repeat again. Angle PLQ equals to angle PLM equals to 90 degrees. They are both right angles. And those two angles actually those two angles angle QPN and angle NPM will be equal to each other or according to third angle theorem. Okay, so angle, it is actually angle QPL, this angle will be equal to this angle PLM, according to third angle theorem. I repeat again. Angle QPL equals to angle PLM according to third angle theorem. So what is third angle theorem? Third angle theorem states that if two angles in one triangle congruent to two angles in another triangle, then the third pair of angles must also congruent. Why? Because it is complementary to 180 degrees. Okay? So if we define angle PQPL is theta, then angle LPM will be also equal to theta because of the fact that they are equal to each other. Okay? And so this angle equals to theta, and this angle equals to beta. Okay, before that, you can see from the drawing that theta plus theta equals to alpha plus beta. Okay, theta plus theta equals to alpha plus beta. I repeat again, theta plus theta equals to alpha plus beta. That is to say 2 theta equals to alpha plus beta. But according to equation number 3, we have already found out that alpha equals to 3 beta. So we can substitute alpha in this equation by 3 beta. And we will get that 2 theta equals to alpha is 3 beta plus beta. That is to say 2 theta equals to 3 beta plus beta is 4 beta. We will divide this equation by 2 and we will get that theta equals to 2 beta. So we found out that theta equals to 2 beta. Here we can write down that theta equals to 2 beta, and here also theta equals to 2 beta. But you can see from the drawing that angle SPR, this angle equals to beta, and this angle equals to theta, and theta equals to 2 beta. So if this angle is beta, this angle must be also equal to beta in order to in order that beta plus beta will be equal to theta, this angle must be equal to beta. Okay, so we found out that angle NPS equals to beta. Because of the fact that beta plus beta equals to theta, then this angle must be equal to beta in order to complete the sum of those two angles to theta. This angle must be equal to beta. Okay. Here, angle MSN or MSQ, it is the same, equals to 90 degrees. Because MS is perpendicular to QR. This angle equals to 90 degrees. And angle PSN equals to 45 degrees. So this angle must be equal also to 45 degrees in order to complete the sum of those two angles to 90 degrees. Then this angle must be equal to 45 degrees, because 45 degrees plus 45 degrees equals to 90 degrees, exactly like this angle that is right angle. So this angle must be equal to 45 degrees. So in the next step we will focus on triangle PNS and triangle PSM. I will copy it again And we will prove that triangle PNS is congruent to triangle PSM. Okay? So we have triangle PNS. And also triangle PMS. So actually we will prove that the green triangle PNS is congruent to the white triangle PMS. Why they congruent to each other? First of all, we know that those two angles, they are equal to each other, they are both equal to beta. So we can write down, so in triangle PNS and triangle PMS. Okay? We will prove that those two triangles can go into each other. The green triangle can go into the white triangle. First of all, those two angles, they are equal to each other, they are both equal to beta. Those two angles, they are both equal to beta. So angle NPS equal to angle SPM, this angle, and both angles are equal to beta. So you can see here. PS is a common side, it belongs to both triangles. So we can write down that PS equals to PS, it's a common side that belongs to both triangles. Okay? And those two angles, they are equal to each other, they are both equal to 45 degrees. So we can write down that angle PSN is equal to angle MSP. And they are both equal to 45 degrees. So we actually proved that the green triangle PNS, is congruent to the white triangle PMS. I write down triangle PNS congruent. This is the sign of congruent to triangle PMS, the white triangle, according to angle side angle rule. What is angle side angle rule? Angle side angle rule states that if two angles and the side that included between those two angles in one triangle congruent to two angles and the side that included in another triangle, then the two triangles can go into each other according to angle side angle rule. And we proved that those two angles and the side between them, that is actually PS, in the green triangle congruent to those two angles and the side that is between them, that is to say PS, in the white triangle, triangle PMS. Therefore, we proved that those two triangles congruent to each other according to angle side angle rule. And from the fact that those two triangles congruent to each other, we will conclude that MS equals to NS. MS equals to NS. Here also you can write down that MS equals to NS. Okay. And if we join points M and N together by a straight line, we join points M and N together by a straight line, we know that this angle is a right angle, angle MSN is a right angle, and those two sides in triangle MSN, they are equal to each other, and we have the rule that in front of equal sides in the triangle there are equal angles. In front of those two equal sides we have those two angles. That is to say, those two angles are equal to each other. So this angle is 90 degrees, and the sum of the angles in any triangle is equal to 180 degrees, so those two angles must be equal to 90 degrees, because this angle is a right angle, so those two angles must be equal to 90 degrees, and they are also equal to each other. They both the sum of those two angles are equal to 90 degrees, and they are also equal to each other. So if we define this angle as y, then this angle will be also equal to y. And y plus y, that is 2y, must be equal to 90 degrees according to the rule that the sum of the angles in any triangle is equal to 180 degrees. So we got that 2y equals to 90 degrees. We will divide this equation by 2 and we will get that angle y equals to 45 degrees. So we found out that angle y equals to 45 degrees. This angle equals to 45 degrees, and this angle also equals to 45 degrees. So you can write here also, we join points M and M together, M and N together by a straight line. We found actually that angle MNS equals to 45 degrees. That is to say, this angle equals to 45 degrees, and this angle also equals to 45 degrees. Okay. In the next step, we will prove that triangle PQN is congruent to triangle PNM. I will draw again these two triangles, and we will prove that they are congruent to each other. Triangle PQN congruent to triangle PMN. And repeat again, we will prove the triangle PQN, the green triangle PQN is congruent to the white triangle PNM, this triangle. Why they congruent to each other? First of all, PQ equals to PM. I wrote it here, that PQ equals to PM. So in triangle PQN and triangle PNM, we prove that they are congruent to each other. So PQ equals to PM. We already found out that PQ equals to PM. We also know that those two angles, they are equal to each other. They are both equal to 2 beta. So angle QPN is equal to angle NPM and both angles, they are equal to 2 beta. And this side PN is a common side, it belongs to both triangles. So we can write down that PN equals to PN. It's a common side that belongs to both triangles. Okay? So we actually proved that triangle PQN is congruent to triangle PNM according to side angle side rule. I'll write it down. Triangle PQN congruent to triangle PNM according to side angle side rule. What is side angle side rule? Side angle side rule is that if you prove that two sides and the angle between them in one triangle congruent to two sides and the angle between them in another triangle, then you proved that those two triangles congruent to each other according to side angle side rule. And we actually proved that those two sides and the angle between them, that is to say 2 beta, in the green triangle QPN, congruent to those two sides and the angle between them, that is to say 2 beta, in triangle PNM in the white triangle. Therefore we proved that those two triangles congruent to each other according to side angle side rule. And from the fact that those two triangles congruent to each other, we will conclude that QN is equal to NM. QN is equal to NM. QN is equal to NM. So I will copy again the triangle QMN. I will copy it here. The triangle QNM So we found out that Qn equals to Mn. This is angle X. Again, Qn equals to MN okay, QN equals to MN in triangle QMN. And we have the rule that in front of equal sides in a triangle there are equal angles. In front of those two equal sides there are also two equal angles, that is to say those two angles must be also equal to each other. So, but this angle equals to x, so this angle must be also equal to x. So we found out that angle QMN equals to x because of the fact that those two sides are equal to each other, therefore those two angles must be also equal to each other, and this, if this angle is x, then this angle must be also equal to x. And according to rule number 4, the exterior angle MNS, the exterior angle in triangle QMN, angle MNS is an exterior angle. The value of this angle equals to the sum of the angles that are not adjacent to it. And the only two angles that are not adjacent to it are those two angles. That is to say, the value of angle MNS will be equal to x plus x, that is to say angle MNS equals to 2x. So we actually found out that angle MNS equals to 2x, but we have already found out that angle MNS, you can see from the drawing that angle MNS equals to 45 degrees. So we can write here that angle MNS equals to 45 degrees. And from this equation, we will conclude that 2x equals to 45 degrees. Here we will divide this equation by 2, and we will get that x equals to 45 degrees over 2, that is to say x equals to 22.5 degrees. So we found out that according to the second method, x also equals to 22.5 degrees. Okay, so now I'll summarize the lecture. So we found the value of angle x using two different methods. Here we have triangle PQR. We know that angle PSQ equals to 45 degrees. Angle PQS equals to 3x, angle PRS equals to x, and we want to find out the value of angle x. We defined angle QPS as alpha, we defined angle SPR as beta, and here QR is a straight line, and we know that the sum of the angles on one side of the straight line is equal to 180 degrees. So if we focus on point S on the straight line QR on the upper side of the straight line QR, we will get that the sum of the angles must be equal to 180 degrees. So this angle is 45 degrees, plus this angle, that is angle X, must be equal to 180 degrees, according to the rule that I mentioned. That is to say, 45 degrees plus X equals to 180 degrees. We subtracted 45 degrees from this equation, and we got that angle X equals to 135 degrees, so this angle equals to 135 degrees. Then I presented to you a new rule that is actually the law of sines. According to the law of sines, in any triangle, if the length of this side is B, the length of this side is C, and the length of this side is A, then this angle is A, this angle is B, this angle is C, then A over sinus A equals to B over sine B equals to C over sine C. From this formula, we will conclude that A over sine A equals to B over sine B, and if we multiply this equation by sine A and we will divide it by B, we will get that A over B equals to sine A over sine B. So it means that the ratio between the side lengths of the triangle equals to the ratio between the opposite angles. Okay? Because of the fact that angle A is located in the opposite sides of the length A, and angle B is located in the opposite sides of the length B. Okay? So we actually created the equation that PS over QS equals to PS over SR. Okay? PS over QS equals to PS over SR. Why? Because of the fact that QS equals to SR, it is true to say that PS over QS equals to PS over SR. And according to the rule that I mentioned, then PS over QS, that is actually the ratio between the side lengths of triangle PQS, is equal to the ratio between the opposite angles. That is to say, PS over QS will be equal to sine 3x over sine alpha. PS over QS equals to sine 3x over sine alpha, and PS over SR in triangle PSR, PS over SR will be equal to sine x over sine beta. PS over SR equals to sine x over sine beta. Then we know that the sum of the angles in any triangle is equal to 180 degrees. So in triangle PQS, the sum of the angles must be equal to 180 degrees. That is to say, alpha plus 3x plus 45 degrees equals to 180 degrees. We subtracted 3x and also 45 degrees from this equation number 2, and we got that alpha equals to 180 degrees minus 3x plus 45 degrees. Then we focus on triangle PSR. We know that in triangle PSR also the sum of the angles must be equal to 180 degrees. So in triangle PSR, it means that beta plus 135 degrees plus x must be equal to 180 degrees. We subtracted 135 degrees from this equation number 3, and we got, and also angle x, and we got that beta equals to 180 degrees minus 135 degrees is 45 degrees minus x. So we expressed the variables alpha and beta in terms of x. Okay, and then we substituted alpha and beta in this equation number 1, by the values that we found for alpha and beta in equations number 2 and 3. And we got that here sinus 3x equals to sinus alpha, and alpha according to equation number 2 equals to 180 degrees minus 3x plus 45 degrees. And it equals to sinus x over sinus beta, and according to equation number 3, beta equals to 45 degrees minus x. And we have the trigonometric identity that states that sinus 180 degrees minus theta equals to sine theta. So we can substitute sinus 180 degrees minus 3x plus 45 degrees to sinus 3x plus 45 degrees. So we did it, and we got that sine 3x over sine 45 degrees plus 3x equals to sine x over sine 45 degrees minus x, because multiplied this question number 1 and we got this expression, and then we multiplied equation number 1 by 2 and we got this expression. Then we use the trigonometric identity that 2 sine A times sine B equals to cosine A minus B minus cosine A plus B, in order to simplify this expression. And we got that this side equals to cosine 4x minus 45 degrees minus cosine 2x plus 45 degrees. And we use the same trigonometric identity in order to simplify this side, this expression, and we got that 2 sine x sine 45 degrees plus 3x equals to cosine 2x plus 45 degrees minus cosine 4x plus 45 degrees. Here we arranged the formula, and we got that that cosine 4x minus 45 degrees equals to cosine 4x plus 45 degrees. Cosine 4x minus 45 degrees plus cosine 4x plus 45 degrees equals to 2 cosine 2x plus 45 degrees. And then we used the trigonometric identity that cosine D plus cosine D equals to cosine C plus D over 2 times cosine C minus D over 2, in order to find the value of this expression. And we found out that this expression equals to 2 cosine 4x times cosine 45 degrees. And according to the trigonometric identity that cosine A plus B equals to cosine A times cosine B minus sine A times sine B, we will get that the value of 2 cosine 2x plus 45 degrees, it is actually equals to cosine 2x times cosine 45 degrees minus 2 sine 2x times sine 45 degrees. Then we divided this equation number 1 by 2 cosine 45 degrees, and we got that cosine 4x equals to cosine 2x minus sine 2x. We added sine 2x to this equation number 1, and we got that sine 2x equals to cosine 2x minus cosine 4x. Here we know that sine 2x equals to 2 sine x cosine x, and cosine 2x minus cosine 4x. We found the value of this expression according to the trigonometric identity that states that cosine C minus cosine D equals to 2 sine D plus C over 2 times sine D minus C over 2. And we found out that the value of cosine 2x minus cosine 4x, it is actually equals to 2 sine 3x times sine x. Then we divided this equation number 1 by 2 sine x, and we got that cosine x equals to sine 3x. And we have the trigonometric identity that cosine alpha equals to sine 90 degrees minus alpha. So according to this trigonometric identity, we will get that cosine x equals to sine 90 degrees minus x. So in conclusion, we found out that sine 90 degrees minus x equals to sine 3x. That is to say 90 degrees minus x equals to 3x. We added x to this equation and we got that 90 degrees equals to 4x. We divided this equation by 4 and we got that x equals to 90 degrees over 4. That is to say 8 equals to 90 degrees over 4 is 22.5 degrees. So we found out that angle x equals to 22.5 degrees according to the first method. So we finished with the first method. Then I presented to you how to find out the value of x according to a second method. In the second method, we define this angle as alpha, this angle as beta. We know that this angle equals to 145 degrees according to the first method. Then we know that the sum of the angles in any triangle is equal to 180 degrees. That is to say, the sum of the angles in triangle PQS equals to 180 degrees. It means that alpha plus 3x plus 45 degrees must be equal to 180 degrees. We subtracted 45 degrees from this equation, equation number 1, and we got that alpha plus 3x equals to 135 degrees. Then we focus on triangle PSR. The sum of the angles in triangle PSR must be also equal to 180 degrees. That is to say, beta plus 145 degrees plus x must be equal to 180 degrees. We subtracted 135 degrees from this equation, equation number 2, and we got that beta plus x equals to 45 degrees. We multiplied the equation number 2 by 3 and we got that 3 beta plus 3x equals to 135 degrees. And according to equation number 1, alpha plus 3x also equals to 135 degrees. So we have one side of those two equations that are equal to 145 degrees. So we can say that equation number, this side of equation number 1 equals to this side of equation number 2. Because both sides are equal to 135 degrees. So we created equation number 3 that states that alpha plus 3x equals to 3 beta plus 3x. We subtracted 3x from this equation, equation number 3, and we got that alpha equals to 3 beta, according to equation number 3. And then we actually, I presented to you rule number 4. According to rule number 4, the exterior angle of a triangle is equal to the sum of the angles that are not adjacent to it. What is the meaning of rule number 4? The meaning of rule number 4 is that if we have a triangle ABC and we have inside triangle ABC we have angles alpha, beta and gamma. So this angle, angle CSAC, is an exterior angle of triangle ABC. What is the value of this exterior angle of triangle ABC? The value of this exterior angle in triangle ABC is equal to, according to rule number 4, to the sum of the two angles that are not adjacent to it. Angle gamma is adjacent to angle SAC. So the other two angles that are not adjacent to it are alpha and beta. That is to say, the value of angle SAC will be equal to alpha plus beta. And we can implement rule number 4 in our drawing, because in our drawing we have the isosceles triangle MQR, and we have those two angles. They are both equal to x, and angle PMQ, this angle is an exterior angle of triangle QMR, and the value of this exterior angle equals to the sum of the angles that are not adjacent to it. This angle is adjacent to it, and the other two angles in triangle QMR that are not adjacent to this angle is x plus x. That is to say, the exterior angle PMQ of triangle QMR equals to x plus x. That is to say, it equals to 2x. Okay, and I forgot to say that we made a construction here from point Q. We draw a straight line. We draw a straight line to PR in such a way that this angle is equal to x. So those two angles, they are both equal to x. Therefore, triangle QMR is an isosceles triangle, and MS is the median to the base of the isosceles triangle, triangle QMR, but the median to the base of an isosceles triangle is not only bisect the base QR, as you can see that QS equals to SR, but it is also perpendicular to the base. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees. Okay? And because of the fact that those two angles are both equal to x, then the external angle will be equal to 2x according to rule number 4. And then in triangle MPQ, PQ equals to PM. So here, because of the fact that this angle is x and this angle is 3x, then this angle must be equal to 3x minus x. That is to say, this angle equals to 2x. This angle also equals to 2x. So triangle PQM is an isosceles triangle because it has two angles that are equal to each other, and in front of equal angles there are equal sides. In front of those two equal angles there are sides PQ and PM, that is to say PQ equals to PM. So we found out that PQ equals to PM. Then in triangle PQL and PQM, we actually, from point P, we drew perpendicular to QM, so this angle equals to 90 degrees, this angle also equal to 90 degrees, and we extended the perpendicular until it touches the QS at point N. Then we focus on those two right angles, triangle PQL and PLM. Triangle PQL and PLM. In those two triangles, angle PQL equals to angle PML equals to 2x. Those two angles are equal to each other, so we have the first two angles that are congruent in those two triangles, those two right angles. Those two angles, they are also equal to each other, they are both right angles. So angle PLQ equals to angle PLM equals to 90 degrees. And the third angle, the third pair of angles, those two angles must be also equal to each other according to the third angle theorem. Angle QPL equals to angle PLM according to third angle theorem. According to third angle theorem, if two angles in one triangle congruent to two angles in another triangle, then the third pair of angles must also congruent. Why? Because it is complementary to 180 degrees, so those angles, they are equal to each other. Therefore, if one angle is theta, then the other angle will be also equal to theta. And as you can see from the drawing, you can clearly see that theta plus theta equals to alpha plus beta. Okay, theta plus theta equals to alpha plus beta. You can see it from the drawing. That is to say 2 theta equals to alpha plus beta. But we have already found out that according to equation number 3, alpha equals to 3 beta. So we can substitute alpha by 3 beta in this equation. So we did it and we got that 2 theta equals to alpha is 3 beta plus beta. So 3 beta plus beta is 4 beta. So we found out that 2 beta equals to 4 beta. We divided this equation by 2 and we got that theta equals to 2 beta. Here we can write down that theta equals to 2 beta, and here also theta equals to 2 beta. So here this angle is angle theta and this angle is angle beta, but theta equals to 2 beta and this angle is beta. So this angle must be also equal to beta because of the fact that theta equals to 2 beta. So if this angle is beta, this angle must be also equal to beta, because beta plus beta equals to theta, to 2 beta, that is theta. So this angle NP S must be also equal to beta. Okay, and here also we know that angle AMSN equals to 90 degrees. But it is given us in the question that angle PSN equals to 45 degrees. So this angle must be equal to 90 degrees minus 45 degrees. That is to say, this angle must be also equal to 45 degrees. Then we proved that triangle PNS is congruent to triangle PMS. Okay, we proved that the green triangle PNS is congruent to the white triangle PMS. Why they congruent to each other? First of all, we have those two angles that are equal to each other. They are both equal to beta. So angle NPS equals to angle SPM equals to beta. And PS is a common side that belongs to both triangles. So PS equals to PS is a common side that belongs to both triangles. And those two angles are also equal to each other. They are both equal to 45 degrees. So angle PSN equals to angle MSP equals to 45 degrees. So we proved that the green triangle is congruent to the right triangle according to angle side angle rule. And from the fact that they congruent to each other, we will conclude that MS equals to SN. MS equals to SN. Okay, here we can write also that MS equals to SN. And then we proved that the green triangle PQN is congruent to the white triangle PNM. Why they congruent to each other? First of all, we know that PQ equals to PM. I want to know that PQ equals to PN because of those two angles that are equal to each other, therefore PQ equals to PN. Okay, PQ equals to PN. And we have those two angles that are equal to each other, they are both equal to beta. And Pn is a common side that belongs to both triangles. So Pn equals to Pn is a common side that belongs to both triangles. So we proved that those two triangles can congruent to each other according to side angle side rule. And from the fact that they can congruent to each other, we will conclude that Qn equals to Mn. Qn equals to Mn. Here Qn equals to Mn. So I draw again triangle QMN. We know that QM equals to MN. So in triangle QMN, we know that QN equals to MN. And we know that in front of equal sides in the triangle there are equal angles. That is to say, because of the fact that QM equals to QN, those two angles must be also equal to each other. But we know that this angle equals to x, so this angle must be also equal to x. Okay, angle MQN, this angle MQN, this angle equal to x, so this angle must be also equal to x. So we know that those two angles are both equal to x, and in triangle QMN, angle MNS is an exterior angle, and the value of the exterior angle MNS according to rule number 4 is equals to the sum of the two angles that are not adjacent to it. The two angles that are not adjacent to it are those two angles. That is to say, this angle equals to x plus x. So we found out that angle MSN equals to 2x from one side, but we have already found out that this angle MNS equals to 45 degrees. So from one side, angle MNS equals to 45 degrees, and from the other side, we found out that angle MNS equals to 2x. From this equation, we will get that 2x equals to 45 degrees. We will divide this equation by 2, and we will get that x equals to 22.5 degrees. So we found out that angle x equals to 22.5 degrees in both methods. Okay, thank you very much.